Hey YouTube, so this is my seventh video, excuse me, on the topic of Panvitalism, and in this video I will be discussing the definition of complexity, and I start by asking the question, why is a formal definition required? We start by wondering what the arguably two most common terms mean within our contemporary scientific and philosophical landscape discerning conversation about emergence and complexity. We start by defining the term complex. We will later define system. A system is complex when it is a system with multiple agents dynamically interacting in multiple ways, following the local rules and oblivious to any higher level instructions. I have added a new fourth reference down below, which will refer back to Johnson, page 19. This initial definition already carries a lot of weight on its shoulders. Let's attempt to dissect it excuse me. Let's attempt to dissect it into multiple components. We may only speak about a complex system if and only if 1. It is an adjective. 2. It is a system. 3. It contains multiple agents. 4. These agents are dynamically interacting in multiple ways. 5. These agents follow local rules. And 6. These agents are oblivious to any higher level instructions. Now, component 1 gives the definition its metaphysical weight. What aspect of reality are we discussing here? Namely, that aspect of reality which is referred to by using adjectives. A discussion on adjectives, nouns, verbs, and other categories of words is currently uncalled for, but it is still important to realize that we are talking about an adjective here. When it is being carried, with it is being carried the entire foundational weight of Anglo-Saxon and continental 20th century and modern-day philosophy of language. Component 2. Component 2 gives the definition its ontological weight. We are using and discussing things. These things are systems. The next logical step in our reasoning is to find out what a system is. We will therefore employ a common use definition of what a system means. By quoting Jaegwon Kim, we discover that a system is, that is, any physical system can be exhaustively described in terms of 1. The basic particles that constitute it. This assumes classic atomism, which the early emergentists accepted. 2. All the intrinsic properties of these particles. And 3. The relations that configure these particles into a structure with substantial unity, as some emergentists would say. Such a description will give us a total relatedness of basal constituents. It also gives us what we may call the total microstructural or micro-based property of the system. That is, a macro-based, macro, since it belongs to the system as a whole, constituted by the system's basic macro constituents, their intrinsic properties, and the relations that structure them into a system with unity and stability as a substance. I've added a fifth reference down below, and the reference is to the Dictionary of Cambridge University. Their definition is one that I think proves my point significantly enough to get over or get across the point that we are talking about a system, and the way that they defined it to me seems like it's good enough for the thing that I am trying to prove with this paper, in this part of the paper. So my comment on it reads, please excuse me from using a common knowledge source instead of a philosophically academic source. To me, the difference between both sources, although vast and difficult to fully comprehend, seems rather unnecessary to employ here. The argument attempted here should still be sound regardless. So, that's what I meant with the argument still being sound regardless. But we have found now a circularity. A system is a system if it is a structured whole, but a structured whole is a structured whole when it is a system. What exactly are we talking about here? Taking a look at the third component illuminates our confusion. Component 3 gives a definition its structural weight. A complex system is a system if and only if it exists out of multiple independent agents that make up its whole. But as we have discussed in component 1 and 2, we are again using terms and concepts that closely resemble each other in order to point at that thing we are trying to distill and separate. As any reader can notice, we are nearing a semantical nightmare. I've added a 7th note with that, and that 7th note says, for discussions on semantical networks, see other works by the author. That is another paper that I'm going to be discussing, but maybe we should continue with the components and do semantical networks after we have finished this component. So we were at the point of the semantical nightmare. Let us therefore admit to the fact that system and complex both have their own unique meaning, but that we currently do not have fitting definitions which resolves all discussion about said topic. Let us then agree to the point that a system requires components in order to be called a system, and that reducing a system to its components means a loss of information. To quote information theory specialists, the field was originally established by the works of Harry Nyquist and Ralph Hartley in the 1920s and Claude Shannon in the 1940s. So we will be talking more about information when we get to that point of the paper. A system can thus have its components, but still forms a different ontological entity than simply the sum of its underlying components. Now, component 4. Component 4 gives the definition its temporal weight. The easiest understanding of what dynamics refer to can be described as using any and all formula that refer to Newton's classical understanding of the laws of physics, and thus the 3 laws of Newton. There is a reason why the word dynamic was used in this part of the definition. It carries with it a long historical baggage which started with the ancient Greek and found its catharsis in the 17th century under the guise of Isaac Newton. Of course, discussion about Einstein would fit this part of the thesis as well, but hopefully the reader can understand the attempt made to consolidate a link between component 4 and Newtonian physics. Component 5. Component 5 gives the definition its spatial weight. It describes the spatial universe or reality wherein these components manifest themselves. Once again, we refer to another famous writer, but this time a bit later than Sir Newton. Immanuel Kant wrote his Critique of Pure Reason in the late 18th century, and with it came a philosophical foundation for the genius insights of Isaac Newton. Our transcendental understanding of time and space will lead us to a rich dialectical unfolding of history, as Hegel would say. But a more interesting aspect of component 5 is that it brings our theory in connection to Bell's theorem. In Bell's theorem, which says that in which quantum mechanics is proven to be incompatible with the premises of locality and reality, our solution solves this problem by tackling the element of locality. Component 6. Component 6 gives the definition its teleological weight, and to understand this component we will return to one of the grandfathers of philosophy himself, Aristotle. The 4 causes that his philosophy describes enriched most, if not all, dialogue about the natural world for the 25 centuries that followed. So here we have found a definition that gives us 6 distinct components to more closely research and investigate. These 6 components are not random. They each fulfill a very specific function with the broader concept as a whole. Again, to even speak of the semantical, I have to resort to terms found in the life sciences, such as biology, as is shown in my use of function. This link with the biological, sorry, I have to edit a wrong point. This link with the biological is not trivial, it is fundamental. Side note, it can also be mathematical, but that's besides the point now. Now, the goal of this semantical dissection was to point out that our current definition of complexity is being spread over way too many semantical and disciplinary areas. On the one hand, we have phenomenon that are described by physics, phenomena it should be. On the one hand, we have phenomena that are described by physics, but on the other hand, it also includes sociology, biology, astronomy, even mathematics. We might as well add many other disciplines to the list of contenders for using the term complexity in order to describe its phenomena. But this current confusion does not have to hold. It can be circumvented by clearly delineating which semantical areas are relevant for every case of complex phenomena. For this, we only need three semantical areas, namely those of information, time, and space. Information in and of itself can further be split into sub-areas of metaphysics, structure, and teleology. We will therefore discuss the compositionality of informationality, temporality, and spatiality next, and see how the compositionality of informationality needs to be broken up into a few distinct components, namely the compositionality of metaphysics, structure, and teleology. This semantical clarity is important to answer all the questions that follow, but it's especially relevant to the question with which we started this chapter. Why is a formal definition required? The answer, because it provides us with better semantical tools to describe reality as we experience it. The next video will be about semantical networks and why that is important for the theory as we are moving forwards. So I hope you enjoyed this video and I'll see you in the next one. Bye.